Today we're going to pull together several things we have already been working on. We're going to pull together what we know about function tables, what we know about equations and graphing and coordinate graphing and all of that, and sort of put that together today. And we're going to also add in the element of being able to look at a situation and decide on the two things that we're saying have a relationship, which one is an independent variable and which one is a dependent variable. But let's first kind of look at the equation and the table and whatnot. So it says you can use a function table to show a relationship. You could also show this on a graph. So for example, Mario buys books at Goodwill that cost $2 each. Write an equation, create a table, and draw a graph to show the total amount he pays for the books. Use the variable y to represent the total cost. So when we think about this, if we want to find the total amount he pays, we're going to have to multiply 2 by the number of books he buys, because it's $2 for each book. So if he bought one book, that would be $2. If he bought two books, that would be $4. If he bought three books, that would be $6, so forth and so on. So in this case, if x equals the number of books he buys, then 2x is how much he pays. So looking at this, then we're going to say if x is the number of books that he bought, then 2x is the amount that he has to pay for the books. So if he buys 3 books, he has to pay $6. If he buys 4 books, he has to pay $8. If he buys 5 books, he has to pay $10. If he buys 6 books, he has to pay $12, so forth and so on. So we get that by doing 2 times 3, 2 times 4, 2 times 5, 2 times 6. And we could do this for any number of books. For example, if he bought 15 books, we could do 15 times 2, which is 30. If he bought 9 books, we could do 9 times 2, which is 18. So no matter how many books he's going to buy, we can absolutely figure out how much those books are going to cost. Now, the other thing we're going to do with this is we're going to create a graph to show the data, to show the data from our function table. When you do a graph from a function table, you're always going to put the x value on the x-axis and the y value on the y-axis. So in this case, the number of books bought and the cost. The number of books is going to be on the x-axis and the cost is going to be on the y-axis. So when we look at the number of books, now we don't have to do the ordered pair 15, 30 and the ordered pair 9, 18 necessarily, but looking at the ones we do have, it sort of looks like for the number of books, we could easily count by ones. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up to 10 books. And then for our cost, when we look at that, we need to go at least all the way up to 12, it looks like. So we probably want to count by, we could count by ones or we could count by twos. We're not going to count by anything bigger than that necessarily because we don't really need to. If we counted by 5s, could we do that? Yes, but is it going to be as easy to graph the data? Probably not. So we're going to count by either 1s or 2s. I'm going to choose by 2s. That's just going to make the data fit our graph pretty easily. So we've got 2, 4, 6, 8, 10, 12, 14, 16, 18, and $20. So when we go and we actually graph this then, now we're going to graph our data. If we buy 3 books, it costs $6. If we buy 4 books, that costs $8. 5 books costs $10. And so notice what I'm doing. I'm saying, well, 3 books, I have to go up that line and then all the way up to where it's going to have a cost of $6. That's how I'm graphing these. Then my ordered pair 6, 12 is the last one that I'm going to graph. Notice when I draw a line that I can actually connect that from 0, 0 all the way through. It's going to continue all the way. It can continue forever. And when I look at this, it actually even gives me information that's not in my chart. Remember, we've talked about this. For example, if I wanted to buy 8 books, I could go up this line and see, oh, 8 books is going to cost $16. Remember, if you think back to when we were doing ratios and ratio tables and whatnot, we also said, well, you can find the unit rate from looking at graphs. For example, 1 book costs $2. So that's our unit rate of $2 per book. So a lot of this part so far should be reviewed. The thing that is not going to be reviewed, perhaps, is this idea of independent and dependent events, and that's what we're going to get into next. When we look at this, we have two variables. We have x and we have y. So looking at this, of those two variables, one is independent and one is dependent. Independent means it's the thing that we choose, and dependent means it's the thing that happens because of what we chose. So in this case, we're going to have that our x value, the number of books bought, is the independent value, because that has to happen first before we can decide how much money we pay. The amount we pay depends on how many books we buy. Now, some things to note. The independent value is going to be the x value, or the input of the function table. Those are going to be the numbers that you choose, and we always graph them on the x-axis. The dependent value is going to be the y, or variable rather, is going to be the y values, or the output of the function table. And it's dependent because the value depends on the independent variable. You have to know how many books you buy before you know how much you pay. So the one you have to know first is the independent variable, and then the dependent variable happens because of it. So this is a little bit like cause and effect in language arts. And the dependent variable is always going to be graphed on the y-axis. Again, in this example, the number of books bought is the independent variable, and the money paid is the dependent variable, because it depends on how many books he bought. Now let's take a minute to look at this and think about the relationships. We want to fill in the box with possible independent or dependent variables for the situation. So if your independent variable is the number of hours you study for a test, well, what depends on that? It could be your grade. That would probably be the most likely candidate, I would say. So we would say your grade would be the dependent variable, because your grade might depend on how many hours you study for a test. How about looking at it the other way? If I give you the dependent variable, can we figure out the independent variable? So, for example, if the dependent variable is the cost of your pizza, what does that depend on? Well, there's a lot of things we could think of. It might be the size of the pizza. It might be how many toppings you get. It might be where you buy your pizza. So it could be any of those things, but again, I want you to focus in on that relationship of dependent event is the thing that happens because of the independent variable. So you would first have to choose, for example, the size of your pizza. Once you choose the size of your pizza, then you can figure out the cost of your pizza. All right, the next one, the number of items you buy at the grocery store. So if that's your independent variable, what happens once we know how many items we're going to buy? Well, things that depend on that might be the cost of your groceries, or how many how many bags you're going to fill, or whether you want to walk to whether you're going to have to carry your groceries home, or get an Uber, or drive home, or something like that. So your dependent variable then might be something like the cost of your groceries. Looking at another example, how long it takes you to drive somewhere. What does that depend on? Well, it might depend on how far you're going to drive, because you have to know how far you're going to drive, and then once you know how far, if I'm only driving 5 miles, it's not going to take very long. But if I'm driving 200 miles, that's going to take a lot longer. So the amount of time it takes might depend on how far you're going to drive. It might also depend on your speed. There's other factors that we could think of as far as how long it takes to get somewhere. So the distance traveled. So the distance might determine how long it takes you to drive somewhere. And last but not least, if our independent variable is the amount of gas in your gas tank. So once I know how much gas is in my gas tank, what can I decide? Well, I might decide how far I can drive, or I might decide how long it is until I need to stop for gas. Either of those could be my dependent variable. I'm going to put how far I can drive. So again, just to summarize, Remember that you can use a graph, you can use an equation, you can use a function table to describe real-world situations and the relationship between your variables. When you look at the variables, there's going to be two things that are variables. There's going to be the one thing that you have to pick, that's your independent variable, and then there has to be the one thing that happens because of that. That's your dependent variable. So again, your grade depends on how many hours you study. The cost of your pizza depends on the size of the pizza. The cost of your groceries depends on the number of items you buy at the grocery store. How long it takes you to drive somewhere depends on the distance, how far you're going to drive. How far you can drive depends on the amount of gas in your gas tank. So the dependent variable, what happens, it's the effect of your independent variable. So you can always, if you've done it correctly, it would make sense to say my dependent variable depends on my independent variable. So when you look at a situation and you decide on that, go back and make sure that it makes sense. Whichever one you picked as your dependent variable, you could fit it in this sentence. Blank depends on blank, my independent variable.